So this is today's lecture. So we're going to functions. We're going to function world. So let's see before. Oops, I need my pencil. Right, some of you may have learned this, something called slope-intercept form. Right, so this represents a straight line. So this is a function. And because it's a function, so this equation, we can write y as f of x. So basically, f of x means a function in terms of variable x. So mx plus b. So this is telling us only x is a variable. So m and b are supposed to be some numbers. Remember in class, we talk about mathematics has two families. One family is the expression. Okay? Another family is the equation. So the mathematical business basically covers these two big branches. And of course, function is an equation. So function is the under equation. So all the functions are equations, but not all equations are functions. So this one, yes. So this equation, yes, can be written as a function, and we write this way. But let's give an example. Let's see, we have an equation y squared equals to 1 minus x squared. This is also an equation, but this will not be able to write as a function. The problem is y being squared. Okay, y being squared, but we talk about this later. We'll talk about this later. So let's see now. If given a graph, so let me erase this. So some equations are functions and all functions are equations. So how can we determine equation is a function or not? An equation, we can draw a graph. We can draw a graph where we use table values. Remember last class, we made a table values. You know, we give x is called an independent variable. We give x some easy values. Then we evaluate y value. Then we get some points. Then we can plug the points onto the coordinates. So we get a graph of the equation. So let's see we have a graph like this. So basically this is a y equals to x squared graph. So if I know the graph, how do I know if this graph represents a function or not? So one thing I could do is I could put vertical line. I can use a vertical line test. Let me see if I can change the color. Yeah, I can. Okay. So you see, every vertical line means perpendicular to x-axis and parallel to y-axis. So you see, anywhere I put a vertical line on this graph, I only get a 1 point overlapped, right? So the vertical lines cross the graph only at 1 point. So bingo, that is a function. That is function. So what's this? Let me give you another example. Let's see, I have this graph for equation x squared plus y squared equals to 1, or y squared equals to 1 minus x squared, as I wrote before. This represents a unit circle. So this is 1, 1, -1, -1. Just imagine this is a perfect circle, unit circle, centered at the origin, 0, 0. So this equation, so those two equations are the same equation. So we can graph, so this is a graph, the circle with radius 1 centered at the origin. This is a graph. And we can use a vertical line test as well. Right. But then we see the difference from the top, right? You see here, I put a vertical line then my line crosses the graph at 2 points. So this is telling me this fails the vertical line test. This tells me, yes, this is an equation, but it's not a function. So not a function, okay? So hopefully you can remember those two examples. Now let's go to this one, first one. The first one, we have two sets of ordered pairs. Ordered pairs are fancy names for points. So 5, 6, 5, 7, 5, 8, 5, 9, 5, 10 represents 5 points. So now so that means I can graph. So determine if each relation is a function. So what does this mean? This means that the first value is x value, second is the y value, so on and so forth. Right? So this is my x-axis, represents my x value. The first member is x value, first member x value. This is my y-axis. The second member, 6, 7, 8, 9, 10, have y values. So I need to go from 6 to 10. Let me draw my graph. Let's draw x-axis here for my convenience, right? So x value, I only need 5. Y value, I need 6. Let's see, this is 3, 6, 9. Okay, 9. We can always mark the increment by our convenience. So the first point is 5, 6. That's this point. Second point, 5, 7, a little bit higher. 5, 8, a little bit higher. 5, 9. Then 5, 10. Right? So now let me draw a vertical line. So all those points fall on this line, right? This is a little bit shifted. And this line has a name, x equals to 5. Okay, this vertical line has a name, x equals to 5. Because we're in two-dimension world. In one-dimension world, x equals to 5 just means one point. But in two-dimension world, x equals to 5 represents a straight line, this vertical line. So you see, vertical line test fails, right? It crossed my graph. My graph, I have 5 points. And my vertical line cross all 5 points. So that fails vertical line test. That tells me the first one is not a function. It's not a function. Well, let's see the second one. Let's go back to draw another one. Second one, I need 5 up to 9 for x value. Then the y value, I need 6 up to 10 again. Let's see, this is 5. This is 10. Okay, maybe this is 6, 7, 8, 9. Then 5, so that's 6, 9, no, 3, 6, 9. All right. So first point, 5, 6, 5, 6, this point. Then 6, 7, 6, 7, 7, 8, 7, 8, 8, 9, 8, 9, 9, 10, 9, 10, right? Then if I draw a line, if I draw a vertical line anywhere, I draw a line at the 5. So this is x equals to 5 line. X equals to 6. Oops, I missed it. X equals to 7 line. X equals to 8. X equals to 9. So on and so forth. It only crosses the graph. The graph also have 5 points, right? Only crosses the graph at 1 point. So that means yes. So the second one is a function. But you may ask, do we have to draw the graph all the time? That seems like troublesome. No, we don't need to. We don't need to. So let's take the shortcut. The shortcut is, if we're given a set of ordered sets, so we check the first member. So the first member is a 5. Oh, 5 again. Oh, 5 again. Oh, 5 again. Oh, 5 again. We actually don't need to check more, as long as we check 2 of them. So we see, okay, we see the first member to be 5, then the second member to be 5. We don't need to go any further. We only have to compare these 2 points for now. Because the first members are the same. Then we check the second member. 6, 7. The second member are different. That tells us it's not a function. If we do have a 5.6, then 5.6 again, then 5.6 again, this all 5.6, that's fine. That would make a function, because this is 1 point. But because we have different values of the second member, but with the same first member. So when the first member the same, but the second value, the y value are different, so that makes no function. For the second one, we check the first member 5, 6, 7, 8, 9. Okay, the first member is all different. So that makes a function. We don't really need to check the second member anymore. The second member can be the same. So that makes a function. All right. So the shortcut is we check the first member. If all the first members are different, that's a function. If somehow some first members are the same, then we check that second member. If the second members are the same, yes, make functions. But if the second member are different with the first members are the same, not a function. Let's see 2. So we want to find f of 3 for the function f of x equals to 4x minus 2. If f of x is a little bit troublesome, you can always think f of x is a y. It's a y value. So that means x equals to 3. So f of 3, so now the input is 3. What does the function do? The function said multiply 4 with the input, then subtract 2. So multiply by 4 with the input is 3, then subtract 2. Well, 4 times 3, 12. 12 minus 2, 10. So that gives us a point. So 3, comma, 10. And we call function value. So f of 3 we call function value for x equals to 3. Let's say b. So h of -1. Right? So t equals -1 now. What does the function h do? Function square the input, subtract 5 times the input, then add 2. So we square the input, we multiply the input by -5, then we plus 2. -1 squared is +1. -5 times -1, +5. Then plus 2. 1 plus 5, 6. 6 plus 2, 8. And this is called evaluation. Okay, so we evaluate a function value at a given point. Well, this one is a little bit troublesome. So the input is x plus 2, right? So let's read the function. So what does the function g do? So if a function is too troublesome, you can also think about at Hunter College, you see the vending machines, right? You see the vending machines give you a panel of choice and give you a slot to input your money. Maybe you input $1. Then this slot give you a couple of choices. You can choose a snack, you can choose a cup of water, stuff like that. So you push $1 in, you press a button. So this machine is a function. You press a button, and the button gives you a snack or anything according to it. So this is just like that. Okay, you put X into the machine. What does the machine do? The machine square the input, then add 2 times the input, then -4. So we just follow this. So now the input is X plus 2. And the machine G is a squared input, then plus 2 times the input, then minus 4, right? Square input is perfect square. Perfect square formula is first one square plus 2 times the first one times the second one. 2 times x times 2, that's 4x. Plus the second one square, 2 square, which is 4. Then this one we distribute 2 times x, 2x, 2 times 2, 4. Then we add 4. Combine like terms, we'll get x squared. We have 4x, 2x, that's a 6x. We have 4 with 3, 4, that's 12. And that's it. So that's g of x plus 2 for the given function as such. Okay, let's see 3. Yeah, 3 and 4, the last 2 questions. 3, we're given function g, okay, machine g, and defined as in the table. So we have these points, right? So the function of 0, 2 as a point, 1, 4 as a point, 2, 6 as a point, 3, 8 as a point. So 4, 10 as a point. And what is this? This is 0, g of 0. Okay. This is 1, g of 1. This is 2, g of 2. This is 3, g of 3. This is 4, g of 4. Okay. So that's why you see g of 4 equals to 10. Okay, this one, second member. And g of 3 equals to 8. G of 2 equals to 6. G of 1 equals to 4. G of 0 equals to 2. Now, let's see, what is the domain and range of G? Domain means the first member. It means x value. So from 0, 1, 2, 3, 4. Right? Range means the function value or the y value. 2, 4, 6, 8, 10. So this is the domain of G. This is the range of G. So what is G of 2? Well, G of 2 is a 6, right? You see x value is 2. So this is G of 2, 6 equals to 6. What's G of 4? X value is 4. G of 4 is 10. Let's see 4. 4, we're given 2 functions. We're given f function as 2x, g function as 2x minus 3. So we want to graph from -2 to 2 for integers. Let's make the table. So this is the x value. -2, -1, 0, 1, and 2. And let's see, this is the f function. So this is f of x equals to 2x. This is g of x equals to 2x minus 3. If you remember from high school, those are straight lines, right? But the high school, we have y equal to 2x, y equal to 2x minus 3. So when x equals -2, 2 times -2, that's -4. When x equals to -1, that's 2 times -1, that equals to -2. So this is f of -2, f of -1. Then f of 0, f of 0 equals, so let me write it, f of 0 equals to 2 times 0, which is 0. This is f of 1. equals 2 times 1, which is 2. F of 2. 2 times 2 is 4. Right? So for f of x, we get these points. We get -2, -4, -1, -2, 0, comma 0, 1, comma 2, 2, comma 4. Like these 5 points. Now let's see what. Well, let's graph it for f first. -2, -4. -2 horizontally, that's the x-axis. From 0 to the left, -2 is here. Then y value is -4. So we go down. So this point is -2, -4. -1, -2, -1 here, -2 here. So this point is -1, comma -2. 0, comma 0 is this one. 1, comma 2 is this one. 2, comma 4 is this one. So when we graph, let me get a straight line. When we graph, that's our graph, right? You see all the points on this straight line. So both of them represent straight line. Now let me change my color to be blue. Let's evaluate the g of x. So the first one would be, so g, what happened? Why it doesn't go back? Oh, okay. So g of -2, that equals to 2 times -2 minus 3. Well, 2 times -2 is -4. -4 minus 3, that's -7. Then this is g of -1. G of -1 is 2 times -1 minus 3. 2 times -1, -2. -2 minus 3, -5. Then this is g of 0. 2 times 0 minus 3. Well, that's -3. Then 2 times 1 minus 3. That's -1. 2 times 2 minus 3. 2 times 2, 4. 4 minus 3, positive 1. So I get -2, -7 at the point, -1, -5, 0, -3, 1, comma, -1, 2, comma, 1. I get 5 points for G. So -2, -7. -2 is here, -7 is here. -1, -5, -1, -5. Second point. 0, comma, -3. Third point. 1, comma, -1. This one. 2, comma, 1. This one. Now let's graph this. Okay, so that's a graph of G. That's a graph of G. Let's compare those two. So f of x equals to 2x. G of x equals to 2x minus 3. You see, basically the graph being pushed 3 units up. You see this point, right? You see the blue color, a push. If we talk about from F to G, G is the graph of F pushed down 3 units, right? This point 0, comma 0, now it's 0, comma -3. You see this point being pushed down 3 units. This point being pushed down 3 units. This point being pushed down 3 units. But if we go from G to F, F is G being pushed up 3 units, right? This is G from G. So this point being pushed up 3 units. This point pushed up, this point pushed up, all 3 units. And those two lines are parallel. Why? Because the slope is the same. Remember y-intercept form, slope-intercept form. You see a number before x is a 2. That's a slope, rate of change are the same. So that's why those two lines are parallel. All right. And that's it.